Welcome back, dear subscribers of the Kunj classes. And if some of you have not subscribed by chance the channel, I may request you to subscribe and keep enjoying good videos from engineering mechanics. Engineering mechanics by the Kunj classes. This is my number. Problem set 2.4, solution to 2.62. Very simple. So far we have been using the method of projections to solve numerical problems. The main thing is you have to identify the points of contact and find the different forces and draw at a given point and draw x-axis, y-axis and find out the forces along x-axis, y-axis. If some of them are not exactly along y-axis or x-axis, you are required to find their projections on x-axis and y-axis and apply sigma x is equal to 0 and sigma y is equal to 0 for the condition of equilibrium. So let us begin with another one, that is problem set 2.4 solution to 2.62, right? So, two smooth cylinders of weight. My battery is running down. I should switch on the battery fast. Then 1 second. Sorry for the interruption. 1 second. Sorry for the interruption. Okay, now it's fine. So we wasted a couple of minutes. It's okay. So let me read out the statement for you. Two smooth cylinders of weight P and Q are placed in a smooth trough. This is a trough. Smooth means there is no friction. As shown in figure, this is the figure S. Determine the reactions at contact surfaces at A, B and C. So, these two cylinders, this one having a weight Q acting from the center of mass vertically downward, this one having a weight P acting from the center of mass vertically downward. The value of P and Q are given, of course. And the points of contact, as you can identify, here is a point of contact, here is a point of contact, here is a point of contact, and here is a point of contact. This distance from here to here is 400 millimeter. These two cylinders are trapped inside it. This angle alpha is also given as 45 degree. And the value of P is 200 Newton, Q 800 Newton, R1. And the radius of this cylinder is 100 millimeter. And the radius of this one is 200 millimeter, and the distance from this point to this point is 400 mm, and alpha is 45. So we have to find the different forces, right? To begin with, don't look at this. Let me redraw this diagram, which I have redrawn in a different page for better understanding. Then we'll come back to this analysis. So let me show you the redrawn diagram. Now I think it's visible. Now this one, center O, its weight is acting vertically downward. That is equal to P is equal to 200 Newton, and its radius is R1 from this point to this point, or same thing as from this point to this point is the radius R1 100 millimeter. And this cylinder is in contact with the surface at here. So there is a reaction force RA at the point of contact to this side. Since the reaction force is normal to the surface, so I have drawn a 90 degree here. This line and this line, they are perpendicular, therefore it is 90 degree. And coming back to the second one, the bigger one, and this one. has a weight Q is equal to 800 Newton, shown from its center of mass acting vertically downward. Q is equal to 800 Newton. And its radius R2 from here to here is 200 millimeter. That is same thing as from here to here is also 200 millimeter. And this cylinder is in contact with the draw at the point C here and here at the point B. This point is C, this point is B, and both have a common point of contact D. So now look here, the reaction force RC, normal to the surface. This is a curved one, so this straight line is the normal. So RC is passing through this point and passing through the center O and is pointing to this side for this cylinder. And for the point of contact D, which is common to both this cylinder and this cylinder, the smaller and the bigger one, this smaller one is applying a contact force here, RD, to this side, and this cylinder is applying the same contact force here, RD, to this side, RD to this side. Now, what else? Now, so RC to this and RC is to this side, point of contact C, and here point of contact B, RB is to this side. Here point of contact D, RD, to this side as well as to this side. This RD is for this cylinder, this RD is for this cylinder, and all the forces are passing through here. Here the forces are passing through O, here the forces also passing through O1, O2, O1. Now look at, so what is given is, let me read out. What is given, P is 200 Newton, that is the weight of this one, acting vertically downward. Then the weight of this one, Q, acting vertically downward, 800 Newton. R1, radius of this, 100 millimeter. R2, radius of this one is 200 millimeter. And the distance between this wall and this wall, which I have shown below the diagram here, from this end to this end is 400 millimeter. And this angle alpha is given as 45 degree. So let angle O1O2E is equal to beta. Let me show you. O1O2E, this angle is beta, suppose. Now since this line of action of RA and the line of action of RC are parallel, and this RD, this line is the transversal, so if this angle is beta, therefore this angle is also beta, corresponding angle. And again, this angle CO2, or let's say RD, this angle is also beta because they are vertically opposite. So let us find out first cos beta. So on this O, from O to P, the line of action of the weight is vertically downward. Therefore this line is perpendicular to RC here. So we have a right angle triangle, OEO2, right angle at E. So cos of beta will be base over hypotenuse, that is EO2 over O1O2. So cos beta is equal to EO2 over OO2. Now how much is EO2? That is interesting to be found out. How much is this length from E to O2? This length will be equal to this total length, which is given as 400 millimeter. This total length, that is given as 400 millimeter, minus 200 from the right hand side, and minus 100, that is the radius of this cylinder from this side. So EO2 is equal to this length, that is 400 millimeter minus 200 minus 100. So EO2 is equal to 400 minus 200 minus 100 over how much is OO1, the distance from O1 to O2. The distance from O1 to O2 is the radius of this cylinder plus radius of this cylinder, that is R1 plus R2, and both are given. R1 is 100, R2 is 200. So your cos beta is equal to EO2 over O1 O2, 400 minus 200 minus 100 over 100 plus 200, that is 100 over 300. Zeros cancel, so 1 over 3. So with a scientific calculator, you find out beta as cos inverse 1 over 3. That comes out to be 70.528 degree exactly. If you convert to degree, minutes and seconds of arc using the same scientific calculator, 70 degree, 31 minute, 43.61 seconds of arc, I will consider only this thing. Now let us apply the free body diagram at O1. Free body diagram at O1. So how many forces? How many forces are at O1? The reaction force RA from this end passing through O1 to this side. This is on 1. Then the weight of this cylinder, that is P, to this side. To this side. Then the reaction force RD to this side. And this angle is beta. This angle is beta, which we just calculated at 70 degree, 31 minutes. So let us draw the free body diagram at point O. So that is what I have done in the first page. So the free body diagram at point O gives the following one. So reaction force RA, the weight of the cylinder P, and the reaction force RD, and this angle I explained how this is beta. So if you drop a perpendicular from this point to this point becomes RD sine beta, and if you drop a perpendicular here from this point to this point becomes RD cos beta. How do you get that? In this triangle, if you take cos beta and cross multiply, you will get this one. If you take sine beta and cross multiply, you will get this one. Means the side of facing the angle will be always in sine, and the side adjacent to the angle other than the hypotenuse will be in cos. So we have resolved this RD into two rectangular components, one along positive y-axis and the other along negative x-axis. And this is already along x-axis and this is already along negative y-axis. So let us apply sigma y is equal to 0. As you can see, this is along positive y-axis and P is along negative y-axis. They are already opposite to each other, and if their magnitudes are equal, then sigma y will be 0. So I have put sigma y is equal to 0, Rd sine beta is P, so Rd is equal to P over sine beta. Beta we just calculated, value of P is given. So put this in a scientific calculator, this comes out to be 212.147 Newton. Fine. Then let us apply sigma x is equal to 0. If you look at RA is along positive x-axis and the component of RD, that is this one, that is RD cos beta, is along negative x-axis, this being the origin. So they are opposite. RA is opposite to RD cos beta. So if their numerical values are equal, then sigma x will be 0. Sum of the forces along x-axis will be 0. So applying sigma x is equal to 0, Rd cos beta is RA. So I have rewritten it here, keeping RA on the left hand side, Rd cos beta. Rd we just calculated, 212.147. So put the value here, cos beta, beta we have calculated, and put whole this thing in a calculator, scientific calculator rather. You get a RA is equal to 70.757 Newton. Right. Now the last part is important. To draw the free body diagram at point O2, we have to have certain imagination while drawing the diagram. So what is interesting at O2 is, at O2 there are four forces. At O2 there are four forces. There is RC to this side, and there is Q to this side. This is already vertical along y-axis, so this will not have any x component. This RC is already along negative x-axis. This will also not have a y component. Now your RB This is RC, this is your Q, then your RD, yes, this is your RD. This is making angle beta with positive x-axis. So if you drop a perpendicular from here, this much from here to here will be RD sine beta, and if you drop a perpendicular here from this point to this side will be your RD cos beta. So let me explain in a new diagram. So the free body diagram at O2, there are 4 forces at O2. Number 1 is RC, which is horizontal, so it has no vertical component. Q, which I just showed, is vertically downward. It has no horizontal component. Therefore, and RD makes angle beta with horizontal. So RD sine beta, RD makes angle beta with horizontal. So RD sine beta, so RD sine beta will be along negative y-axis, that is in the same direction as Q. That is in the same direction as Q. Now RD sine beta from here to here will be in the same direction as Q. Now similarly RD cos beta along positive x-axis, that is in the same direction, that is in the direction opposite to RC. Look here, if you drop a perpendicular here, this component of RD will be RD cos beta, that will be opposite to RC. Now, so 3 forces are okay. We are fine with these forces. This has 2 components. These 2 are already, one is horizontal, one is vertical. So we are left with only one force, the 4th force. So we need to find the angle RB, the 4th force, that it makes with any axis, let's say x-axis or y-axis. Then only you can resolve this into 2 rectangular components. Then we apply sigma x is equal to 0 and sigma y is equal to 0. So I have redrawn the diagram for this cylinder. Resting on an inclined, making an angle alpha with the vertical, not with the horizontal, with the vertical, I have redrawn it here. So this angle is given as alpha. If you draw a horizontal line, this will be 90 minus alpha. Its weight Q is vertically downward. Its value is given as 800 Newton. And from this point your RC was to this side, and this point of contact was your B, and the reaction force was passing through this point to this side. Now the question is how this angle is 90 minus alpha, right? This angle is beta, that is already explained, RD, making with the horizontal. Now look, this is alpha. If you draw a horizontal line, this will be 90 minus alpha. This is horizontal, this is weight, perpendicular to it. So this is 90. So in this triangle, this angle will be alpha, because the sum of the 3 angles, this plus this has to be 180 degree. Since this is alpha, then this angle will also be alpha, vertically opposite, and here it is 90. This is alpha, so this will be 90 minus alpha. So this one, which I have shown it here, will be 90 minus alpha. So RB makes 90 minus alpha angle with the vertical. So its component, one component will be from here to here, and another component will be from here to here. So now let us apply sigma y is equal to 0. So the component of RB along positive y-axis will be RB cos 90 minus alpha, and Q is to the opposite to that, and again the component of RD along this side will be this one from here to here, that is RD sine beta. So Q and RD sine beta, they are in the same direction, so they are added, and RB cos 90 minus alpha is along positive y-axis, so they are opposite to each other. Now put the values. Q RD was found out. Sine of 70 degree 31 minutes, because that was beta. This exactly comes out to be this. So sine alpha goes to the other side, it will be divided. So your RB becomes 999.999 over sine 45. Put it in a scientific calculator. This comes out to be RB is equal to 1414.212 Newton. So we have applied sigma y is equal to 0. Now let us apply sigma x is equal to 0. For the point O, sigma x is equal to 0. RC is along negative x-axis. Now RB cos 90 minus alpha. If this is 90 minus alpha, then this will be alpha. So this will be your RB cos alpha. RB cos alpha and RC, they are opposite to each other. And one component of RD to this side will be RD cos beta. So now let me switch over. So RD cos beta and RB cos alpha, these two are in the positive x-axis. Watch it again. If you drop a perpendicular from here, this will be your RD cos beta. If you drop a perpendicular here, this will be your RB cos of this angle, which is alpha. They are in the same direction, and the sum of those two is being opposed by RC. So I have made them equal here. For sigma x is equal to 0, just put the value of RB cos 45. RD was found out, cos of beta. RC comes out to be 1070.756 Newton. So may I request you, if you like the video, just feel like giving your comments, and if you really happy, you can subscribe and let others, and you can pursue others to do so. Okay, thank you.